Hi everyone. In the last video, we went through integration using substitution method. In this video, we'll find out integrals using partial fractions method. Integration of rational functions using partial fractions. How do we integrate if we have functions like this, where you have a polynomial function in the numerator and polynomial functions in the denominator? This is where we will have to use partial fraction method. What is a partial fraction? Partial fraction is nothing but it's a method used to decompose. Decompose is nothing but break down these polynomial functions, right, as sum of the rational functions. So if you notice here, you have x plus 2 by 2x minus 1 into x minus 3. Now we cannot split this. There are two terms in the denominator. In such cases, what we do, we use this partial fraction method and split it like this, right? And here we split it in the form of addition, right, as a sum of rational functions. Now when I try to solve this or resolve this, I will get this particular function back. Now this method of splitting these rational functions into sum of rational functions is called as partial fraction method. So if we express this as sum of rational functions, then it is easy to integrate. You can integrate this separately like this. Integrate this portion separately and integrate this portion separately. So that's why we use this particular method. When we have rational functions, there are two types: proper rational functions and improper rational functions. Now what is proper rational function? Degree of numerator, if it is less than degree of denominator, then it is called as proper rational function. Now what is degree of numerator? So take this particular example. Degree is nothing but the highest power. The highest power in that particular function is the degree. Now if you look at degree of this particular function is 1. There's nothing here means there is 1. So degree is 1 here. This is degree. Now look at the degree of denominator. Here you'll have to multiply this, that is expand this. Once I multiply, I'll get 2x into x. I'll get it as 2x square. I'll get 2x square. Now notice what is the degree? Degree is the highest power. So 2 is the highest power. 2 is the highest power for the denominator function. So for numerator, it is 1. And for denominator, it is 2. The degree in the numerator is less than degree in the denominator. So this is proper fraction. This is proper rational fraction. Now let's look at an example for improper rational function. X square plus 1 by x square minus 5x plus 6. Here you see the degree, highest degree is 2 and highest degree of x in the denominator is 2. So it's equal. And in this particular example, the highest degree of x is 3 and highest degree in denominator is 2. This is greater, right? This is equal to and this is greater. So here, if the numerator degree is equal to or greater than the denominator degree, then we call this as improper rational function. If you need more details on partial fractions, there is a detailed video on the concepts and multiple problems. Now let's take few examples and find the integral of rational functions. Let's take this first example. Please notice that in the question they normally don't give this integral symbol and dx, but you'll have to put integral symbol and dx. How do you identify if you have to apply partial fraction method or not? First thing, right, given a question, if you have functions in the form of division, you have functions in the form of ratio, this is a polynomial, and in denominator also you have polynomial, and if there are product of multiple terms in the denominator. Also, if you cannot split it, can you split it? I can't split this, right? In such cases, use partial fraction method. So they wouldn't specify which method to be used, but we'll have to figure out, looking at the problem, as to which method needs to be used. Now first what we will do is, we will split this. How would we split this? We will have to first write down this, equate it to, we'll have to put a with this particular term, x minus 1. Then we'll have to put addition symbol and b with this particular term, x plus 2. We'll have to find a and b. So using partial fraction method, we can find a and b. Now we will take the LCM. Take LCM. So what will happen when I take LCM? LCM for this is x minus 1 into x plus 2. This and this. This and this is the LCM. you get confused with the LCM approach, just cross multiply. That is, I can write a into x plus 2 plus b into, like this, I cross multiply. A into x plus 2 plus b into x minus 1. And then I have to multiply the denominators here and put it in the denominator. So this would be 4x plus 5. Let me copy this as it is. Now this and this, both of them can be cancelled. So now what I am left with? So what do I get? I get 4x plus 5 is equal to a into x plus 2 plus b into x minus 1. Now I'll have to find the values of a and b. What I do is, I take x plus 2 equal to 0. So I get x is equal to minus 2. So now I put x is equal to minus 2 in this particular equation. So now I'll substitute x is equal to minus 2 in the entire equation. So I'll get 4 into minus 2 plus 5 is equal to a into minus 2 plus 2 plus b into minus 2 minus 1. So I'll get 0 plus minus 3b. And this will be minus 8 plus 5, which is minus 3, which is nothing but b becomes 1. Now similarly, I'll take this particular term and equate it to 0. So I'll get x is equal to 1. Now I'll put x is equal to 1 in this equation. So I will get 4 into 1 plus 5 is equal to a into 1 plus 2 plus b into 1 minus 1. So this will be 3a plus 0, 9. Therefore, a is equal to 9 by 3, which is 3. So b is equal to 1 and a is equal to 3. Now what we will do is, we'll substitute the value of a here, value of b here, and we would get this rational function. So let's substitute a and b in, let's call this as equation 2. Let's substitute a and b in equation 2. So what do we get? A by x minus 1. So it will be a is 3 by x minus 1 plus b, 1 by b by x plus 2. So 1 by x plus 2. Now we will have to start finding the integral and dx. So now what is integral of this term? It is 3 log of x minus 1. 1 by x minus 1 is log, because integral of 1 by x is log x. Now instead of x, we have x minus 1. So we can consider x minus 1 as t, right? I can substitute x minus 1 as t. So what will happen? I'll get integral of 1 by t, which is log t. Then I put t as x minus 1. So I'll get log x minus 1. Similarly, integral of this term is log x plus 2 and plus c. Let's not forget this plus c. So this is the answer. Now let's take this particular problem. Slightly tricky, but it's simple. We have e to the power x and e to the power 2x. Now how do we solve this? Normally, if you have something like x square plus 2x plus 6, you can factorize and find the factors. But here we have e to the power x. What do we do? So what we will do is, we'll substitute e to the power x as t, right? We are telling let t be e to the power x. Now if I differentiate, I will differentiate now. If I differentiate this entire expression, I'll get, let me write this as t is equal to e to the power x. When I differentiate, I'll get dt. You have to differentiate with respect to x. So I'll get dt by dx. What is the derivative of e to the power x? It's e to the power x itself. Now, this means dt is equal to e to the power x into dx. That is, I shift this here. So it will be e to the power x into dx is equal to dt. Now, what I will do is, I will substitute t and dt in this expression. So I'll write this as integral of e to the power x dx. Notice this, e to the power x dx, same as this. So I can substitute this e to the power x into dx as dt, right? So it will be 3 into dt. Now, instead of e to the power 2x, what is e to the power 2x actually? It is e to the power x into e to the power x. E to the power x into e to the power x is e to the power x plus x, which is e to the power 2x. This is using theory of indices. Now, so e to the power x is t. So it will be t into t, which is t square. So I'll write here as t square plus 5 into e to the power x is t plus 6. I can put this 3 outside. So this will be 3 integral of dt by t square plus 5t plus 6. Now let me factorize this. That is, I have to split this. What I will do, I'll use sum product method. You can use any method to find the factors. I'll use sum product method. So t square plus 5t plus 6. I should get sum as 5 and product as 6. So I'll take two numbers. I'll take 3 and 2. When I multiply, I'll get 6. When I add, I'll get 5. So the numbers are t plus 3 and t plus 2. 3 and 2 are the numbers, right? 3 and 2 are the numbers. So I will write this as 3 integral of dt by t plus 3 into t plus 2. Now I'll have to use partial fraction method. Why? Because I have a rational function here and there is no way I can split this. So I'll use partial fraction. So what I will do, I'll just take this portion, right? Only this portion I'll take. Let's leave 3. We'll resolve it later when we find the integral. So let's say, consider dt. Let's not put dt, let's put 1, right? There's nothing here, we'll consider as 1. 1 by t plus 3 into t plus 2. Now this you can write it as a by, take this term, t plus 3, plus b by, take second term, t plus 2. Now let's find the values of a and b. I can use LCM or cross multiply. LCM or cross multiply. So a into t plus 2, I'm cross multiplying, plus b into t plus 3. Then I multiply the denominators. So now I'll cancel both of this. I'll be left with this equation. So I'll get 1 is equal to a into t plus 2 plus b into t plus 3. I need to take t plus 2 equated to 0, which means I'll get t is equal to minus 2. So put t is equal to minus 2 in this equation. I'll get 1 is equal to a into minus 2 plus 2 plus b into minus 2 plus 3, which is nothing but 0 plus b is equal to 1, which is nothing but b is equal to 1. Now I'll have to do the same thing for second term also. T plus 3 equated to 0. So I get t is equal to minus 3. So now put t is equal to minus 3 in equation 1, in this one. I'll get 1 is equal to a into minus 3 plus 2 plus b into minus 3 plus 3. So this will become minus a plus 0 is equal to 1, which is nothing but a is equal to minus 1. So we got values of a and b. Now we'll substitute these values of a and b in this equation. Let's call this as equation 2. Substitute a and b in equation 2. What is that? A by t plus 3. A is minus 1. So minus 1 by t plus 3 plus b. B is 1 by t plus 2. Now let's go back to the integral. What was it? It was 3 integral dt and this entire thing. Now instead of this entire thing, we have come up with this particular form. That is a by t plus 3 plus b by t plus 2. This entire thing is expressed in this form. But we'll have to put 3 and dt back, right? So it is like this integral, 3 is outside and then we have dt. So now when we find the integral, 1 by t plus 3. What is 1 by t plus 3? We can write it as log t plus 3. Minus is there. Let's put 3 outside. Plus this is log t plus 2 and plus c. Now it's straightforward, you put log here. But if you get confused, just put this t plus 3. You can substitute t plus 3, say as some variable z. So I'll get minus 1 by z plus 1 by, and I can say t plus 2 as something else, say a. So now what is integral of this? Integral of 1 by z is log z, right, with minus sign. And integral of 1 by a is log a. What is z? Let's substitute. Z is t plus 3 and log a is t plus 2. It is easy when you have t here, but in case there is 3t or 2t, right? In case you have, say you have 4t plus 3, then what do? Simple. If it is 4t plus 3, it will become log 4t plus 3. Take the coefficient of t, that is a number adjacent to t. and divide by that number like this. Log 4t plus 3 by 4. That's all. So this is nothing but minus 3 log t plus 3 plus 3 log t plus 2 plus c. Now I'll rearrange this. So 3 log t plus 2 minus 3 log t plus 3, I've just rearranged, plus c. Now I have to substitute t, right? Now what did we assume t as? T as e to the power x. This is what we assumed. T as e to the power x. Now let's substitute e to the power x here. 3 log e to the power x plus 2 minus 3 log e to the power x plus 3 plus c. Now using logarithmic properties, this is of the form log m minus log n. When you have something like this, you can write it as log m by n. So what I will do, I'll anyway take 3 common here, right, between these two, and I'll write log m by n. So this is like m and this is like n. So I'll write e to the power x plus 2 by e to the power x plus 3 plus c. So this is the answer. 3 into log of e to the power x plus 2 by e to the power x plus 3 plus c. Now let's take another example. Now you'll have to always figure out if it's proper function or improper function. You notice here the degree of numerator is 2 and degree of denominator is also 2. So whenever the degree of numerator is equal to degree of denominator or greater, that is numerator degree, if it is greater than or equal to denominator degree, then it is improper. It is equal here. In this case, it's equal. So it is improper. So how do we solve for improper? We'll have to convert this improper fraction into proper. To convert this, we'll have to use division method. That is nothing but you take the denominator or divisor, right? This is divisor. Put the numerator here. This is the numerator. This is the denominator. I have to get x square. To get x square, with what should I multiply x square with? 1. X square into 1 is x square. Now we'll multiply this 1 with this entire expression. So it will be minus 4x minus 12. Now I'll put minus. So x square and x square will get cancelled now. So I'll be left with 3x plus 4x, which is 7x. Minus 2 plus 12 is plus 10. So we don't have anything to carry forward. So we are done here. So this is the remainder. This is the quotient. And this is the divisor or denominator. Now how we'll have to phrase this is, we'll have to make it as quotient plus remainder by divisor or denominator. So I'll write quotient is 1 plus remainder is 7x plus 10 by divisor is this one, x square minus 4x minus 12. So now this is the proper fraction. We have converted improper fraction into proper. Now we'll take the original function. What is the original function? Integral of this entire thing. Instead of this, we'll have to put this. So we'll have to put it as like this. 1 plus 7x plus 10 by x square minus 4x minus 12. Now this is the original problem. Now we'll have to use partial fraction method because there is no way we can split this, right? There's no way we can break this down. Now we'll use partial fraction. We'll first factorize this. X square minus 4x minus 12. If I factorize, I'll get numbers as 6 and 2. Minus 6 into 2 is minus 12. Minus 6 plus 2 is minus 4. So I want these two numbers. So it's nothing but x minus 6 into x plus 2. These are the factors. I use sum product method. You can use any method. There are multiple methods. Let's only take this portion, right? Let's take only this portion. We'll resolve this into partial fractions. Once we are done, we'll substitute in this entire expression and get the integral. Now we'll take this. So we'll take 7x plus 10. We'll write this as x minus 6 into x plus 2. Now this has to be written as a by x minus 6 plus b by x plus 2. Now I'll cross multiply. So I'll get a into x plus 2 plus b into x minus 6 by x. I'll multiply the denominators. So I'll copy this as is. Now this side and this side will get cancelled. These two will get cancelled. So we are left with 7x plus 10 is equal to a into x plus 2 plus b into x minus 6. Now I'll put x is equal to minus 2. X plus 2 you equate it to 0, so you get x is equal to minus 2. Now put x is equal to minus 2 in this equation. So I'll get 7 into minus 2 plus 10 is equal to a into 0 plus b into minus 2 minus 6. So I'll get minus 8b is equal to, so this is nothing but b is equal to minus 4 by minus 8, which is nothing but half. So b is equal to half. Now we'll find a. Now what we'll do, we'll put x is equal to, we'll take this, we'll have to put x is equal to 6. So I'll get 7 into 6 plus 10 is equal to a into 6 plus 2 plus b into 0. So 8a is equal to 52. Therefore a is equal to 52 by 8, which is 13 by 2. A is equal to 13 by 2. Now I'll substitute both of this in the original function in this one. In this one I'll substitute. The partial fraction would be a, that is 13 by 2. I'm substituting in this. So it will be x minus 6 plus b. B is half into x plus 2. Now I'll substitute this entire thing in the main function. This is the main one, right? In this I'll substitute 1 plus 7x plus 10 by x square minus 4x minus 12. This is equal to 1 plus 13 by 2 into x minus 6. I'm replacing the partial fractions here, plus 1 by 2 into x plus 2 dx. Now I'll integrate. So if I integrate, I'll get, what is integral of 1? It's x. What is integral of 13 by 2? What is integral of x 1 by x by 6? It's log x minus 6. And this is half log x plus 2. And let's not forget c. So this is the final answer. Now let's solve this particular problem. So what do we do here? Right? We need to get this in a quadratic equation form. Right? So what we will do, we'll take log x as t. Right? We'll say let log x be t. So once we substitute, we'll have to differentiate. Right? We'll have to always differentiate after we substitute. So what is derivative of log x? It's 1 by x. And this will be dt by dx. Right? I'm differentiating with respect to x. So dt by dx is 1 by x, which is nothing but dx into 1 by x is equal to dt. Right? I just moved this to the left hand side. So dx into 1 by x is dt. Right? Now I will substitute here. Here it's 1 by x. Right? It's x here, and I assume that there is 1 here. So it's 1 by x dx. Look at this. 1 by x dx. 1 by x dx. It should be dt. So let's substitute here. So it will be dt. Put 6 outside. And 2 we have. Instead of log x, we'll put t. T the whole square plus 7t plus 5. Now we'll factorize this. We'll find the factors of this. Sum is going to be 7. Product is this and this. I'll multiply 2 into 5, 10. Now the numbers would be, if I add I should get 7, and if I multiply I should get 10. So the numbers would be 5 and 2. 5 into 2 is 10. 5 plus 2 is equal to 7. So numbers would be 5 and 2. So what should I do here is, I have to take this original expression, and so I'll have to split 70 as 5t and 2t plus 5t plus 2t plus 5. So now I'll take common. So I'll get t 2t plus 5 plus 2t plus 5. I'll take 2t plus 5 as common. So I'll get t plus 1. So the factors are 2t plus 5 and t plus 1. The fraction would be 6 into, let's substitute here, dt by 2t plus 5 into t plus 1. Now we'll use partial fraction. Let's leave out 6 and dt. There's nothing here, let's consider it as 1. So let 1 by 2t plus 5 into t plus 1 is equal to a by 2t plus 5 plus b by t plus 1. I'll cross multiply t plus 1 plus b by 2t plus 5 by multiply the denominators. So I'll copy this here. This and this will get cancelled. So I'll be left with 1 is equal to a into t plus 1 plus b into 2t plus 5. Now let's find the values of a and b. So put t is equal to minus 1. T plus 1 is equal to 0. Take this term. Therefore, t is equal to minus 1. So I'll get 1 is equal to a into minus 1 plus 1 is 0 plus b into 2 into minus 1 plus 5, which is nothing but 3b is equal to 1, which means b is 1 by 3. So b is equal to 1 by 3. Now let's find a. So to find a, I'll have to take this term 2t plus 5 equal to 0. Therefore, t is equal to minus 5 by 2. Now I'll put t is equal to minus 5 by 2 and substitute in this expression. So I get 1 is equal to a into minus 5 by 2 plus 1 plus b into 0. So I'll get minus 3 by 2 into a is 1, which is nothing but a is equal to minus 2 by 3. Now what next? Let's substitute the values of a and b in this equation. So we'll get a is minus 2 by 3, and what is the term? 2t plus 5. 2t plus 5 and plus b. What is b? 1 by 3, and what is the term? T plus 1. Now let's go to the main integral function. This is the main integral function, right? 6 integral of dt by 2t plus 5 into t plus 1. Now we can write this as 6 integral of minus 2 by 3. We'll copy this partial fraction plus 1 by 3 into t plus 1 into dt. Now 6, what is the integral of this? Minus 2 by 3 log of 2t plus 5, and put the coefficient. What is the coefficient of t? What is the number next to t? It's 2. So divide by 2 plus this is 1 by 3 log of t plus 1, and this, what is coefficient of t? Which is 1. That's why we don't put anything, because coefficient of t here is 1 plus c. So remember one thing, integral of 1 by x is log x. That's why here we have 1 by 2t plus 5. So we are putting it as log 2t plus 5, and we take the coefficient of t, which is 2, and divide by 2 here. Let's solve this. 2 and 2 will get cancelled, and we can take 1 by 3 common. So I'll take common 1 by 3 as common. So I'll rearrange. I'll bring this log t plus 1 minus log 2t plus 5 plus c. And here 3 1s are 3 2s are. So this is nothing but 2 into log t plus 1 minus log 2t plus 5 plus c. Now this is of the form log m minus log n. I can write it as log m by n. So this I can write as 2 log of t plus 1 by 2t plus 5 plus c. Now let's not forget to substitute t. What did we assume? T as t is equal to log x. That's what we had assumed, right? So instead of t, we'll put log x. So we'll get log x plus 1. 2 instead of t, it's log x. 2 log x plus 5 plus c. So this is the integral. This is the final answer. With this, we've come to the end of this particular topic. If you've liked this video, do press a like and share it. Thank you.